Okay, I do have this one. There's a circle. Let me take. So let me keep. There's a one simple example is what I'm trying to take to explain the thing. So there are the three coherent. So let's assume that S1, S2, S3, R4 are coherent. S1, S2, S3, and S4 are. And there's no any initial phase difference between them. Initial phase difference, all are having zero initial phase. Okay, fine. So I agree this. So this will send a wave. Let let this be equal to say lambda. What is the radius of this? Let it be lambda. And the wavelength of the waves, let it be equal to lambda, that one. So this will send a wave. They will arrive at point P. Point P is what? Center of the circle. First, individually due to each wave, we'll say like this one. S1, S2, S3, S4. Then the resultant intensity at point P. Only when this is on, when all are off, then only when S1 is on, these two are off. Or when two are on, if all are on, what will happen to the resultant intensity at point P? So what is I naught? Let I naught be the are identical coherent sources. Let I naught be the intensity at point P individually due to each source. Is it okay now? The condition is what I'm putting here. No, only when all are, what is this intensity? So IP, I'll write it. It should be 0. Is it okay? When all are this one, and there's no initial phase, I'm putting that one. This is the first part of the problem we are discussing. No, when only S1 is on, how much intensity should be? I naught. Because all these are switched off, I'll stand at point P. The waves arrive here. This will cover some part. What will be that? The intensity at this point, particular point, let it be I naught. That's what I'm given. Let I naught be the intensity at point P individually due to each source. Then when S1 and S2 is on, what do you expect intensity here? 2 I naught? Anybody? These two are on. So what is the path difference between these two waves? 0, no? If the path difference is 0, tell me like, what is the interference, constructive interference? Then what is the resultant intensity at that point? Given by this formula, 4 I naught. Are you getting back? You must think, see, in every problem, you are supposed to think, what is the path difference of the waves arriving there? That's all. Your numericals, the rest all mathematics, you try to think only this one. From geometry, calculate the path difference of the waves arriving at point P. Agree this, if path difference n lambda means something 0, lambda, 2 lambda, constructive interference. Path difference if it is equal to this delta y. Yeah. If the path difference is equal to this much, okay, not this one. Yeah. Yellow color one, what I shaded is what a student has to think. From the diagram, you should find out. So now look at this one. What is the path difference? This way will cover a distance how much? Lambda. This will cover a distance lambda. Agree this. So then what is the, I'll better write, let lambda be the radius of this. Okay, no, able to understand, no? What is the path difference of the waves arriving at 0? Then it should be constrictive interference. Then how much intensity should be? 4 I naught. Okay, got this idea? No. This will cover how much of length it will cover? Lambda. This will cover the distance lambda. This will cover lambda. Now 3 waves are there. We have a formula only for what? 2 waves. Am I right? When 2 waves undergo superposition, then what is the expression for intensity? This is a formula. It is like, see, I'm telling this one. Don't think that I'm teaching new. If you think that I'm teaching new, there's a big problem is there. There's nothing but vector addition. How to add 2 vectors as we have a formula. If more than 2 vectors are there, anybody, can you suggest any formula? If more than 2 vectors, how to add? Can we use the formula r square equal to p square plus q square 2 pq cos? No, that formula is applicable only for more than 2 vectors. Similarly, don't say this concept is applicable. This is for any number of waves. That one. Now here what happened? This is formula is applicable only for 2 waves only. So therefore, this I cannot use now. So what shall I do now? I will go for, because what is this intensity at this point? I'll calculate the resultant amplitude. Now you go for SHM concept. What is the amplitude of the signal here? Let it be A due to A this way. So how much resultant amplitude will be 3A? It's telling I naught. I naught is proportional to, let's say that, A squared. So what is the resultant amplitude at point P will be? AP is equal to 3A. Then squaring this, what we get? Squaring this one, 9A square. So this will become 3A whole square. So shall we write like this? Agree this. So what is the resultant intensity at point will be 3 I naught. Don't. Or 9 I naught. Anybody? Should be 9 I naught, no? Why to write so many steps? 9 I naught, sorry. This will be IP. So intensity at this point will be 9, not 3 I naught. Similarly, intensity at point P is equal to 4A. A plus, some of you are asking, sir, why 4A? I'll add up. I'll write some steps. It'll be easy for you. Squaring this. Okay, got the idea now? So what is resultant intensity at point P? When all are turned on, 16 I naught I'll get, not 4 I naught. If 2 sources are there, you have formula. More than 2 sources, what you should do? First calculate resultant amplitude, then square it. Okay, agreed? Like that, I just wanted to give information, 2 sources, more than 2 sources. That's why I just picked up this problem. Now, if there is any phase difference initially,